I am honored and privileged to introduce the most eminent and distinguished speaker of Day 2 session, Dr. P.S. Hiremath, Professor, KLE College of Engineering, Hubli, to our participants. Dr. P.S. Hiremath sir has completed his MSc in 1973 at Karnataka University, Dharwad. In 1978, he completed his PhD at Karnataka University, Dharwad. His research areas include image processing and pattern recognition, computational fluid dynamics, and computer networks. He also worked as chairman, Department of Mathematics and Computer Science, member of Syndicate and Academic Council in Gulbarga University. He has over 45 years of teaching and research experience serving in various institutions. In 1978 to 79 in National Institute of Technology, Surathkal, Karnataka. From 79 to 80, Coimbatore Institute of Technology, Coimbatore, Tamil Nadu. From 1980 to 86, National Institute of Technology, Tiruchinappalli, Tamil Nadu. From 86 to 93, Karnataka University, Dharwad, Karnataka. And from 93 to 2014, Gulbarga University, Gulbarga, Karnataka. And from 2014 till date, he is working in KLE Technological University, Hubli, Karnataka. He has successfully guided 18 PhD and 32 MPhil students. He has over 220 papers in various international and national journals and also written 5 books. Also, he is a life member of Indian Society of Theoretical and Applied Mechanics, ISTAM, IIT Kharagpur, and also Ramanujan Mathematical Society, University of Madras, Chennai, and Indian Science Congress, Kolkata. With this short introduction, I wholeheartedly welcome our today's speaker, Dr. P.S. Hiremath sir. I welcome you, sir.
Thank you. Thank you very much.
Without further delay, I request Dr. P.S. Hiremath sir to start the session. Over to you, sir.
Okay, thank you. Firstly, I thank Professor Sharmila for inviting me to participate in this STTP. And also I thank Dr. Saifuddin for his kind words of introduction. Right? And without much ado, let me start my lecture by sharing the screen. Good morning to all the participants. And as indicated in the schedule, so my topic for discussion now would be the machine learning context for the data analytics in the healthcare domain. Right? So first, I will take you to the emerging technologies that have been visible in the current year 2020. Gartner is a company which surveyed thousands of technologies that have been innovated, and then the efforts have been made to realize this into the product form. That is right from the ideation stage to prototyping, and then productization, and then commercialization. So you see, if you see the left-hand side, the innovation that in all these technologies which you see on the left side of the curve are the emerging technologies, and they are in the proof of concept stage, right? Ideation, and there have been proof of concept has been done, and prototyping has been done. So it gives rise to a very high expectation that will get into productization and then commercialization and then marketed in a big way and put to the service to humanity. But not all technologies will see the light of the day. Very just for the sake of economic viability and the practicability in marketing that in the human population. That is, all technologies are not consumed by the human society. Only those technologies which make a great impact on the quality of human life to a considerable extent, they survive as a realizable, a commercial technology. Otherwise, many of the technologies die at the product at the commercialization level itself, right? So this is represented by a hype curve, and is also called as a hype cycle, right? So any technology, when it is ideated by a scientist or a technologist, right, and then it gives hope that it can be realized. That is, first productization is done, prototyping is done, and the production is done with a great hope that it could be marketed commercially, but not all, right? So that is why the hype, that the expectation dies down and reaches a plateau value over a period of time. Only few technologies have survived for a long period of time in the human society. If you look at just the range of technologies that have been emerging, you see I will draw your attention to the self-supervised learning. We have seen supervised learning techniques and unsupervised learning techniques, and self-supervised learning techniques is more natural, right? It is more heuristic based, right? That is guided by AI concepts, right? And then generative adversarial networks, GANs, right? And then the adaptive machine learning, right? That is machine learning techniques which adapts to the changing nature of the data over a period of time, right? And then composite AI, right? These are the variants of artificial intelligence, composite AI, that is multiple, that is AI techniques are, are, uh, are, are employed in a combo fashion to solve a certain problem, right? Generative AI, generating the samples using AI techniques for the experimental purposes, and then responsible AI, right? And then you see AI augmented development, that is augmented reality. We have seen many products, right? But we want the augmentation at the development stage, right? Any productization, right? That process should be augmented by the AI, right? Technology. And then the data fabric, embedded AI is another one, right? Where it is chip based artificial intelligence for signal processing or image processing, right? That we see in automotive electronics or IoT applications, especially in edge-based computing, right? This embedded AI is a big role, right? So this is, and finally, we have seen that explainable AI, that is, the artificial intelligence comes out with a certain inference based on logical processes, logical inferences, and then it also argues, right, why it is a valid inference, right? So not only the algorithm produces the inference, but also explains why it is a valid inference that is drawn. That is explainable AI, right? So this is how the machine learning context, right, combined with the AI techniques, right, is a technology, is an emerging technology for many applications, right? And in every application, we have a scenario of analyzing the data for the purpose of learning about the system. The system behavior is depicted by the nature of the data that originates from the system, right? And data mining was doing that job earlier. Basically, the parsing was done on the data stored, structured form in databases, and then unstructured databases, right? And then we have data analytics, and then we call it as a larger we call it as data science, because it's a convergence of multiple scientific disciplines which are involved in analyzing data for the purpose of understanding what it is trying to say about the system where the data originating from, right? So this is the importance of the machine learning, right? And here I'm going to focus the machine learning and the techniques for analysis of data that originates in the especially with reference to healthcare domain, right? And all these techniques are generic in nature. They are applicable to data analytics in any sector, right, of human activity, whether it is business or commercial or manufacturing, or a product or a business intelligence, right, a marketing, all activities, all spheres of human activities where the technology intervention is there, the data originates and analyzed and then effectively used for the efficient functioning of that system, right? That is a larger goal, right? So focusing on the healthcare data, right? And the technology that have been developed for the analysis of this data, right? It is very resourceful. Data is very resourceful. We almost treat it as a new oil. And the technologies that analyze this data and come out with useful inferences, especially for diagnostic purposes in the case of individuals, and healthcare strategies for dealing with the population health or public health, right? That is a cohort of patients or a population whose health is continuously monitored. And in case of any outbreak of any epidemic or pandemic, we should have growth of that, of the spread of that, and then come out with effective strategies to counter the growth of that by vaccination and medication. We have to have a strategic plan for that because crores of rupees are involved in such a big exercise. So we should have a definite strategy to deal with this situation, right? For that, we require the technology intervention, right? And these technologies are largely based on the machine learning techniques. Basically, the machine learning techniques we require for to learn from the data. And artificial intelligence is to come out with inferences based on some logic. Since you are dealing with vague data or uncertain data, we have to make use of the fuzzy logic. Right? And the neural networks and deep learning are machine learning techniques to learn data and classify them for suitable drawing up. So we have a combination of fuzzy, right, fuzzy neurological networks, right, and combined with deep learning. We go for deep learning because we have to develop the predictive models because we need predictions which will guide us to strategize the plan of action and then implement them or execute them in treating the patient or in protecting the public health, right? And the technologies that have been evolved in this exercise are the computer vision based on image processing. Image is also a data. So the image data is analyzed for the purpose of understanding the image content, the information in the form of image. And then the augmented reality is another technology. We are very familiar with the GPS. When we drive a car, GPS will guide us as we are in the motion. Turn left, turn right, turn right after 500 meters, like that. So that is the augmented reality. That is, human capability is augmented by this technology intervention to deal with a real time task, right? So this is a simple, and then robotics is another big technology, right? We call them disrupting technologies because they have impacted the systems, the efficiency of the system put to use in public domain with a greater impact, right? And the analytics is dealing with a big data context, right? And very quickly, I'll go through the nature of the data, that is the data environment that prevails in the healthcare domain, right? That is organizations which are concerned are dealing with the healthcare of the individuals, that is patients, or the individuals in the public, right? For better healthcare delivery, healthcare service delivery, right? The data need to be analyzed. But the daunting task is the very nature of the data. The data is very heterogeneous, right? It is in text form, in the form of medical reports, notes of the doctors, etc. Whenever they do the inspection, right? That is case papers, right? These are all in textual form, right? And some are typed and some are handwritten, right? So all your document image processing techniques uh, for printed documents and handwritten documents using image processing techniques, right? The full range of technologies developed for document image processing are applicable here, right? And NLP is also a technology that is relevant for handling this kind of data. And then we have got the images which are generated by scanning the particular organ or the whole body scanning. And the devices that have been devised for this purpose of images, the full spectrum of the electromagnetic, the full range of electromagnetic spectrum is exploited for the purpose of generating images of the internal anatomical structures and their pathological functions, right? And physiological functions of those organs. And if any pathology is there, and then we must be able to see it in those images. That is the idea. Without cutting open the body, that is, without any incision on the skin of the human body, we can radiate the human body with certain range of radiation, and then the reflected radiation is captured and then analyzed and then processed for generating image on the computer screen. That is what we do. We have got X-ray images, the very first device, right? X-ray images, and then we have got microscopic images to see very minute organization organisms or the minute cell structures, even electron microscopes which can see the chromosome structures, right? And then polymer molecules or protein molecules, right? Very high resolution electron microscopic are used to see the greater details at the molecular level of the cell biology, right? And then we have got the endoscopy. That is, you can insert a camera, tiny camera, and also a source of light by puncturing a small hole on the human body and insert, and then illuminate the internal anatomical structures and capture the video of that. So with minimum invasion, the doctor is able to see the internal structure and see and examine, right? So this is a great computer-aided techniques which assist the medical experts, right? And also we have got MRI, magnetic resonance imaging, especially for scanning the brain, right? And even other organs also, kidneys and other also we MRI use knee structure, especially orthopedic surgeons make use of X-ray and MRIs. And ultrasound scanning is non-electronic. That is, it is not in electromagnetic range. it is safe, right? Electromagnetic radiation poses danger, especially in the gynecological context. If you are examining the baby in the womb, then the X-ray or MRI are not recommended. So the only way is ultrasound imaging. That is, high frequency sound waves are sent into the body, and then the different layers at different depths. The tissues will reflect these ultrasonic waves, and there is a lot of interference among these reflected sound waves, which are captured. These patterns are captured by the transducer, and then imaging is generated on the computer screen. So whole gadget of these biomedical instruments are intended to support the medical experts to see information about the body, to examine the human body, right, and analyze the functioning of those organs, and then plan for surgery if necessary, or plan for a course of treatment in case of medication, right? And the images are two-dimensional signals, and some of the physiology of the organs are examined by using one-dimensional signals, especially ECG is for examining the functioning of the heart, and EEG is the signals coming from the brain, right? We have got the headgear where there are multiple probes distributed over the cranium of the brain, and then the signals originating, electrical activity that is happening in the brain generates these very feeble electrical signals which are amplified 1,000 times, and those signals are analyzed, right? And that will tell about the physiology of the brain and the mental activity that is happening in the brain, because the mental space resides in the brain structure. So anything that happens in the mind, in the mental space, right, naturally affects the signals originating from the brain. That is the electrical activity, and hence the signals that originate. So the signal analysis of ECG will tell about how healthy is the heart, and EEG signal analysis will tell us the mental state of the person, right, whom you are probing, right? So you see that the data that is originating in the medical domain is of such a highly heterogeneous structure, heterogeneous in nature, and of variety of types, right? Not one type, right? You have got a heterogeneous structure and of varying type, right? And you have especially if you are dealing with, this is about the patients, right? And you have a group of patients, especially in hospitals, you have got databases, right? Databases in the hospital where all these medical records are stored in electronic form, right? For either telemedicine purpose or for analysis purpose, for research, right? This data is utilized, right? And nowadays, the automation in the health, right? Health is treated as an industry. So corporate health organizations, right, which are very large in size, catering to a large number of parents per day, thousands of parents per day, then a lot of automation in this diagnostic process, where all the patient data is captured, stored, and transmitted from one section to another section electronically. So doctors immediately get these reports on the computer screen, and they analyze and diagnose and then recommend a course of treatment for the patient, right? So this is how the database technology and which will, this is a multimedia database, right? It is not a simple database. It's a multimedia database, and large number of records are stored, right? And information retrieval is another research area where the techniques are developed to retrieve multimedia data from such databases for analytic purpose, right? So we are just discussing the nature of the data. Nature of the data is very important to understand to come out with very effective data analytic techniques. And if you are concentrating on the population health or public health, right, mostly the government agencies and also partly some big hospitals provide data about the public health, government hospitals and government departments, as for example, Department of Health and Family Welfare, right? These are government departments, huge departments. They have got very huge staff continuously engaged in collecting uh, the data of the public health, right? Recently, you must have seen in the COVID scenario, there are mobile apps. I think Aryoga Setu app, many of you might have registered, where you very frequently you have to register and re-register because the purpose is to capture what is your current health condition. Do you suffer from any heart disease or any other morbidity, comorbidities, right? Diabetes and all those things, asthma, right? That health condition is captured on a continuous basis. And that is, there is a time access for that. And then it will guide you how many people are right infected around you like that. So you have got mobile technology very effectively used and web-based right technology to guide you, to inform you that your how risky, right? How you are exposed to a risky environment in your immediate neighborhood. That is a great technology intervention in the service of humanity, right? This is what we talk about. But what about the time of what is the nature of the data here? The nature of the data is a spatial distribution of the data over a geographical location, geographical distribution of the data, right? That is called spatial distribution of the data, right? From locality to locality, from city to city, from district to district, like that, countrywide and global. So you have a data globally, which is geometrically distributed, and the data is acquired and stored along a time axis. For the last 1 year, 12 months, data about the COVID data has been gathered. So we have a time series of the evolution of the and the spread of the pandemic over the globe. So that data is there, right? So if you analyze the data, then you will understand, right? It will help the scientists to come out with predictive models. That is, what is the portion of the population that will be affected in coming few days. So using those models, that is the government agencies can strategize their plan. They come out with a strategic plan to deal with this pandemic in terms of how to care, how to provide care for already infected people, and number two, how to protect the healthy population from being infected, and thirdly, the efforts to come out with a proper vaccination and arrange for trials. And then if the trial is successful, then have a strategic plan for vaccination of the entire population on the surface of this earth. Then only the human species is protected on this surface. I'm only telling you the scale at which the analytics of the data has to be done. It is not only a data, heterogeneous data, the very size of the data, and it is the evolving data along a time axis, along a timeline. So we don't have enough time, right? We have to act fast to minimize the loss of life due to this pandemic. So this is the challenges which are posed in the context of population health. And in this context, the data that is gathered about the public health locally and at various levels, and globally also, like World Health Organization, where it is a UNO body, right, dealing with the population health globally, right? So the scale is very large. It scales from village level to global level. So your data analytics techniques and all the database technologies to store that data, right, of this nature, and the analytics done on such stored data, your technology must be competent to handle, competent and relevant to handle this challenge, right? And the routine tasks of this is the nutrition. That is, the large population of the poor countries suffer from malnutrition. So that means the portion of the population is danger because of the malnutrition. So what are the strategic plans for that? So this data is again of geospatial temporal data, right? Fertility about that is the birth rate, mortality, the death rate data. So this combination of birth rate and death rate will tell us the population growth on the surface of the earth, population growth country-wise, state-wise. So you have the population growth models, mathematical models. We will be able to predict in another 10 years, 20 years, what would be the population, provided the current health is like this, parameterized by the birth rate and the death rate. Right? In the case of pandemics or epidemics, these rates are affected locally and sometimes globally in the case of pandemic. Morbidity data, morbidity means the diseases that suffered by the individuals, for example, diabetes, right? Large population, what is the percentage of population suffering from diabetes, right? Suffering from heart diseases, suffering from mental diseases, right? Insomnia, because these are occupational hazards of the present population which are exposed to such industrialized environment. So the population suffers in a greater scale in terms of these diseases. So we should have data. This data will help us to come out with a strategic plan to deal with such morbidity incidences. So I have spent a lot of time in discussing the kind of data you are handling, right? So naturally, your mind must have comprehended all these characteristics of the big data. Normally, we have 5 V's, right? The big data, I think most of it is almost in undergraduate studies also, in undergraduate program also, this big data is technology is introduced in the curriculum. We teach normally the 5 V's, the volume, the velocity, variety, veracity, and the value, right? Large data size, right? You just recall the discussion I did a few seconds back about the healthcare data, right? It is very voluminous, right? And geographically distributed. Velocity, the data at which the data is being gathered in the databases, in the computer storage, is very high. And if you are having IoT application, you have a streaming data, right, which will land into your computer storages. Then variety of data, the data is in various formats. That also we are discussing in greater detail. The healthcare data is highly heterogeneous and rich in variety, right? And veracity, the correctness of the data. And since it is gathered in the hospitals and the government agencies, which are continuously monitoring the population health, so it is correct. So veracity, it is authentic data. And the value of the data for decision making. Now I want to prepare a strategic plan, right? Because I have to invest crores of rupees for a healthcare program. So I have to make a strategy. And for strategy, the decision making is important. For decision making is based on the inferences drawn by the data analytics. And the analytics of what data? The analytics of the data which is collected in the recent past, not 100 years old data. That will not help us to prepare plan now. So I should have recent 1 month data, one year data, 5 months, 5 years data, like that. That will help us to utilize the time series analysis of the data will help us to predict and make decision based on those predictions. So the data value is very important. That is another fifth characteristic of the big data, because you have a time series data which has been acquired over a period of time and then stored. So we can time series techniques and analysis techniques are useful here. To give a very simple example, a newspaper, we get newspaper every day. Today's newspaper is of value today, but tomorrow the same piece of paper is a radhi, right? Useless, totally useless. We do it for some other purposes. Only the tomorrow's newspaper is valuable for tomorrow. Today's paper is useless. That means the value of that newspaper is only for one day, right? Like that. This is a very simple example. Even if you look at the employee, right? What is the value addition I give to my organization, right? So long as I remain active in my research, in my teaching, in upgrading myself in terms of the new knowledge that is being generated and needs to be delivered for education of the students. So long as I'm able to contribute to these activities in the institution where I'm employed, I'm of value to it. Once I stop doing these activities, I do not add any value to that organization. Naturally, then I have to come out. Right? If I don't come out, then I will squeezed out by the system, by the rules and regulations. That is, I have to retire. Right? Like that. Right? So the same thing is faced by the data that has been stored. Right? If you are if you are talking about the data value, it depends upon what kind of analytics you are doing on the data and for what decision making. Accordingly, the data value arises. Right? The variability, right? These are the new dimensions of the big data, or the new aspects of the big data that makes sense in the context of geospatial temporal data, because changes in data, because for example, if you are talking about the temperature, right, of the atmosphere in a city, right, if you watch the temperature throughout the 24 hours, right, 24 hours, the morning temperature is different, early morning temperature is different, noon temperature is different, afternoon temperature is different, right? And night, evening temperature is different. That means as time passes, clockwise, the temperature changes. But the magnitude of the temperature is not same in all the cities, in all the countries. All over the surface of the earth, the temperature is not same. Now, in Mangalore, the temperature is different. In Delhi, it is different. In Calcutta, it's different. In New York, it is different. That means the change in data occurs both in space and time. So large variability of the data due to the geospatial temporal distribution of the data. That itself poses challenge for the analytics, right? And this is what is the COVID data, right? The challenge of the analytics of the COVID data. This is the challenge. And another one, due to the enormity of the data that is being handled, we cannot generate the reports in a tabular form and ask the expert to go through the table. Enumerated data make no sense for them. So we have to present the inferences drawn in a graphical form so that the strategists or strategic planners will comprehend what the data is trying to say, what are the inferences, so that it will help them. If they grasp and comprehend the inferences drawn out of these technologies, they will be able to take the decision properly, right? So that is the idea. So any graphic display or in visual form, the information is quickly comprehended by the human brain. So this is another research area. Visualization, data visualization is another research area where the behavioral science also becomes important. That is psychological behavior of the analyst or the decision maker, and how he looks at this visualization is also important, right? Because ultimately decision making is done by the human beings. These are all supporting technologies, right? These technologies must be very effective in providing support to the decision maker so that he comes out with precise decision, right? Otherwise, any imprecision decision, it will be very costly. Very costly. It may be involving crores of rupees investment in the healthcare sector, right? So the decision has to be more precise. That requires very precise analytics. Not only that, the inference is drawn by the analytics must be effectively conveyed to the minds of the decision makers. That is where the visualization becomes important, right? Especially the dashboards, right? The interfaces, the visual graphical user interface is a research area where this activity, this analytic will help us, right? Right. So we want products, right? Humans want products, gadgets with such graphical user interfaces so that he can grasp what is the computer output very quickly and perform his activity. That is the objective of research in this visualization. So that comes as the seventh dimension of the big data, right? So in the case of medical domain, right, not only the first five V's, the last two V's, variability and the visualization, pertinent to the geospatial temporal distribution of the data is concerned, these two become very important in the data analytics. Right? So this is, I think we have understood the nature and characteristics of the data that is originating in the healthcare organizations, right? It is both health administration and government administration departments. This is the kind of data they need to handle, right? So now, if you look at, the earlier how the data mining was done, and then supported the decision making, right? Decision making by the expert, that is diagnosis, arriving at a correct diagnosis is the decision making process, right? So all these, that is when a patient comes, all his symptoms, etc., are clinical symptoms and pathological proofs, all they are gathered, and already you have aggregated data in the databases, right? And already you have built some system to classify this query into a proper class, and that is the decision, right? This is a very typical one. Now the transformation is the medical equipment themselves transport the data, acquire and communicate the data, especially the IoT domain, right? Right. You have the sensors, the equipments which have various kinds of sensors to acquire data about the patient and the patient's body, right? And then process it, right? And this is the kind of data in various forms that need to be analyzed, right? So the scenario has changed. The computing platform has changed, right? And large amount of data of big data type, right? And analytics has to be performed on this. That is machine learning techniques, competent, upgraded, right? And made competent to handle the big data context and come out with inferences, right? For decision making about the individual patient to treat him, and the public health care data to protect the health from certain pandemics or certain morbidities, right? The strategic plan has to be evolved and then executed based on these decisions. So this is the transformation of the analytic process because of this new technology intervention. This is a research area. This is where we have to do the research. And what are the technologies that have emerged, right, and made impact, uh, quick impact on the healthcare delivery? And we call them as exponential technologies. So we have a list of here: cognitive computing, benefited by the advances in artificial intelligence and machine learning, right? Digital medicine, right? The medicine, right? Telemedicine, etc., and the preparation of the medicine that is precision medicine, right? And then you have got blockchain because you have a geospatial temporal data. So the data is geographically distributed and stored in various servers, in multiple servers, in various data centers spread across the globe. So you have a distributed ledger technology called as blockchain. So our data is residing and distributed, right, in this form. And you have to perform analysis of this data, right? That means you have to transform your machine learning techniques. You have to learn from the data which is residing in a distributed form like this, right? And then we have to use AI, artificial intelligence, to come out with inferences, right? So you have got robotics for example, robotic surgery. The patient is in some location and surgeon is in some other location, and they are connected by wireless communication network and the electronic equipments, right? So the surgeon is able to see the patient and organ. He is going to perform the operations, and he has got the controls, and the actuators are in the location of the patient. So any controls he performs for the purpose of surgical actions, the actuators perform actual operation on the patient's body, right? And whatever he is doing, he is able to see on his computer screen, right? And here you must have realized computer vision is the technology that is used, and the rapid communication, wireless communication technology. So it is a convergence of computer vision technology and communication technology, high speed communication, right? It is that is within seconds. After the controls are applied by the surgeon, because surgery happens, the sequence of surgical operations happens in the mind of the surgeon, and affected through the controls. And then actuators are affected by these signals and then perform on the tissues of the patient. So this the time gap between the occurrence of the action on the surgeon side and the surgical operation incident event at the patient side, this time gap should be very minimum, right? So it requires a greater skill on the part of the surgeon, because he should be aware of the time gap, and accordingly he should continue with his sequence of operations, and he has to see it on the screen, right? So a lot of computer vision and automation, right? Convergence technologies is realized in this robotics, right? And additive manufacturing, it is in the manufacturing sector. Manufacturing what? Manufacturing the biomedical instruments, biomedical devices for not only treating the patient, but also monitor and care the patient, right? Very common. This nowadays you have seen the oximeter is available, right? People are advised to buy oximeter to see the oxygen level and the pulse rate of your body every day, right? You can monitor yourself, right? Around 2,000 rupees, 3,000, those very small devices, they are visible. That is the technology intervention, right? The consumption of the technology, these new technologies into the human society is so impactful and so deep into the human society, right? And that is responsible for it is possible because of this additive manufacturing in the manufacturing sector, right? So the crowdsourced, that is naturally public healthcare data, is drawn from the human population. So it is a crowdsourced data. Arogya Setu app data is a crowdsourced data which you can use for the analytic purpose or using time series analysis and monitor the spread of the pandemic and whether it is under control or whether the second wave is going to whether the second wave is predicted now, right? All these how they are doing, they are able to predict first wave is dying down and second wave is likely to occur and when it occurs in which month. So these predictions are possible because of this geospatial temporal data that is captured through these mobile apps, right? So we have got the crowdsourced data, which is analyzed by these applications and come out with predictions and which will help the strategic planners to come out with effective strategies in managing this COVID situation, right? Same thing, so for any epidemic which is localized, some districts or some states, etc., right? The same models, right? The same situation arises, right? And this is another area, that is synthetic biology is another area where that is manufacturing the drug to treat to kill the disease causing the bacteria, right? Viruses, right? So how to that is the cell right, molecular biology, right? The drug molecules, right, are manufactured and the mathematical modeling and simulation techniques are used to see how effective these molecules are in identifying the viruses and germs in the human body and then absorb those molecules, all those proteins into these injected drug molecules, so that they disappear from the blood, right? So this lot of research at molecular biology research is required to design such drug molecules and experiment them. Experiment where simulation experiments are performed for self. If you look at the present day context, the vaccine, the research, vaccine research for COVID, right, is taking place for over nearly 12 months. Huge effort with the support of all these technologies, right? And the technology support, there is the medical scientists, pharmacologists, right, and biologists were under 24 by 7 efforts, right? They have taken 12 months to come out with some vaccines which are on field trial, and within few months or few days, they are likely to perform the vaccination of the population in a graded manner, geographically distributed. They have a strategic plan for that. And all this geospatial temporal data that we have gathered here, it is a support is a support to plan such a vaccination strategy, right? So right from drug discovery to vaccine productization, and then the product delivery in a very large scale to treat the entire population or to protect the entire population is a very massive exercise. Millions of dollars are involved in this. So you can just imagine the importance of the research in this area, where the data index is playing a very big role in coming out with effective strategies to meet the challenges posed by these uh, pandemics and such epidemics, right? And virtual and augmented reality is another technology, right? Another technology that has made impact, right? Now, I've just listed some of the technologies that have emerged and are effectively used very quickly for treating the population, right? For protecting and treating the patients. So with these technologies, you must have seen how what is the value addition of these exponential technologies, which have made great impact in providing healthcare service delivery, right? That is the surgical operations, right? Supported by artificial intelligence, machine learning, big data. All these technologies hold promise for healthcare delivery and surgery, and personalized monitoring in the form of electronic wearable devices, that is wearable electronic devices which monitor the health of your body on a continuous basis and report to the concerned medical expert, and then alert them and then render advice to you without loss of time. So you have got IoT application in such scenario, which makes use of these sensors, right? Virtual reality and wearable devices, and all these are networked, right? Using the IP addresses. So you have got IoT application in medical domain, right? And then your manufacturing technologies, right? And all the future research. And what is important here is the devices with the natural language interface. If you want these technologies, wearable devices and all these with a graphical user interface, they are effective if they are able to communicate. If these devices are able to communicate with the patient in the local language. And how many languages are there on the surface of the earth? Right? Hundreds of languages. So this is another research area where NLP technology is used in developing graphical user interfaces using natural language interfaces pertinent to or relevant to that particular locality where these devices are employed for public healthcare monitoring and servicing, right? Service delivery, right? So this is another area. Very big companies are engaged, right? This is where NLP is another, NLP, natural language processing, is another area of artificial intelligence, right? There are two main areas in AI. One is the robotics, and that is the natural language processing. Robotics, we have seen how impactful it is in medical domain. And similarly, NLP also makes a greater impact in medical domain as a technology, because this technology absorption is great if the device comes with a natural language interface. So the people who are engaged in natural language, engaged in NLP research, they also have a role to play in medical data analytics. Right? I've told you NLP will help us in developing graphical user interface, right? And then equip the devices with such devices based on NLP. So such technology devices can be consumed very rapidly in the human society. So this technology absorption is great when the device comes with these technologies. That we have experienced in our own mobile daily, right? Even illiterate people are able to use the mobile devices because they come with the apps which are provided or rendered using natural language processing, right? So that is how the mobile, next to television technology, first is the radio technology, and then and then the television technology and the mobile technology are the three technologies which are very rapidly absorbed by the human society because they make great impact on the quality of human life in terms of the activities they perform, right? Likewise, we want these devices which are productized in the healthcare domain must be similarly consumed by the public, by the human population, so that it will protect the human population and maintain good quality of health in a larger context, right? And if having seen the value chain of these technologies, evolving technologies, and you see the healthcare workers, the doctors, nurses must be trained during their education program itself to deal with such technology which are intensely used in the healthcare domain. So these experts, medical experts, must be trained, made aware of, must be trained in the usage of these equipments, right? So that the healthcare delivery becomes more intelligent and precise, right? So having seen this, we will see some of the devices, right? These are the companies, right, which are coming out with these devices: retina selfie, hologram, right? This is ID avatars, right? So these devices based on the driving technologies are AI, robotics, augmented reality, right? All those things. Very quickly, I'll go through. These are already productized, but the cost is prohibitive. So the absorption into human society is not much, except in the hospitals, right? And surgery itself is transformed by the use of robotic surgery. You see here the robotic surgeon, right? Surgery here, right? Orthopedics, right? So all these are supported by these technologies, artificial intelligence, augmented reality, and all. These are the companies who are engaged in R&D, right, efforts to come out with such devices, Dassault systems and medical modeling, etc. Right, and this is the Google, right, Omada, this USC. That these are companies which are engaged in cognitive recognition-based devices, right? And similarly, these are other areas, right, for developing robots and augmented reality, right, right. And this is biological research, right? That is at the molecular biology, right? Not just cell biology. The information is required about the details of the cell structure, the molecular structure of the cells, right? Cytoplasm, nucleus, and chromosomes. These are all the cellular structures which are made visible by electronic microscopy, high resolution electron, that is uh, transmission electron microscopy, right? SEM, that scanning electron microscopy, right? These are all electron microscopes which make these details visible on the computer screen with different resolutions. And that is how the nanotechnology has become relevant and very largely used in developing the medicines and deliver it at the nanoscale, right? The nanomolecules, the drug molecules are delivered to the viruses, right? They're injected into the human body, and they are released near the site of the pathological site where the viruses are there and affecting the tissues. There the medicine is released, right? This is what we talk about precision medicine, right? So this is where the mathematical modeling and simulation, right, will help us. These are the computing paradigms, are the platforms where the AI and data analytics is very much used to bring these measures into reality, right? So this is another, right? These are another companies, right, which are dealing with, right, this longevity, that's all, right, chip-based monitoring, etc., right? That is genomics. That is the uh, genomes are the information that are stored in the long protein molecules in the chromosomes, right, of the cells, right? Any defect is there, hereditary defects can be rectified by altering the molecular structure of these genomes. So this is how the medicine, the medical experts in the medical domain are working at the polymer chain level, right? So data analytics plays a very important role in such applications, right? So this is, and very quickly I draw your attention to, right? The population data will help us to estimate the risk. The population is at risk or at high risk, and when only the people, when they start getting symptoms of some disease, then only they approach the hospital and enter the hospital. But we are talking, and then once they enter the health system, right, and the hospital system, they are diagnosed and treated and all those that. And 80% of the healthcare cost is due to these 20% people who enter into the hospital, right? And what about the population which is outside the hospital? They are at risk, but they have not entered the hospital. And some portion of population are developing risk, but not at risk, right? So we have to identify that portion of the population and bring awareness to them, so that they are made healthy, or they are asked to remain healthy, so that they are not exposed to health risks and then develop systems and enter the system. So the money that is spent for this purpose justifies justifies the cost reduction, because those people, if they are aware and they are health conscious, they do not come to the hospital and overload these hospitals and increase the cost. So this is how our healthcare data modeling, public health data analysis, analytics will help us in strategizing these activities and spend money to protect the public health. Right? This is what a lot of research, statistical modeling, probabilistic models are developed by machine learning techniques, because data has to be analyzed, machine learning to be used to come out with the parameters which govern those models, right? The values of the parameters of the mathematical and probabilistic models which you have built, they have to be determined with greater statistical inference, right? At 5% statistical inference, right? The confidence limits must be very high. So the statistical inference techniques are used to determine the parameters of the model, mathematical models, which are learned from the healthcare data, right? So it is a statistical study, and very effectively used in monitoring, planning, and controlling the public health. We call it as public health management, right? So these are as a computer scientist, with the discussions, your mind must have thought of already the data challenges which I have listed here. Large scale of the data, high dimensionality, semi-structured, distributed data, right? All uncertain, vague data, incomplete data, right? All typical vagaries of the data that is analyzed by these techniques, right? And the challenge here is that the critical decisions, because we are dealing with the life of the humans and the life of the human population, right? Any wrong decision will grossly affect the humans and the human population, right? And of course, we can't do work in isolation. We have to work in cooperation, in cooperation with, right, with the medical experts. So it is a collective, cooperative, collaborative effort of computer scientists and the medical experts in dealing with these data analytic challenges. Right? The result, the outcome of these efforts is going to be the intelligent care delivery system, This is a big picture of intelligent care delivery system where we have got the data that is gathered through web applications, right, stored in various databases, right, structured, unstructured, MongoDB, or blockchain technology, whatever technology you deploy for this maintaining these databases and perform analysis with some what kind of decision you want to, for what kind of situation you want to do you want to analyze the data, right? It is not one Ramabana, right? For different decision making, different analytical techniques have to be employed. So you have got various analytical techniques, uh, uh, some predictive models, some inferencing, right? Or parametric inferencing of the models, right? Because it is a time evolution of the data. You have a time series. So you have to periodically update your models, predictive models, whatever you have built, how periodically you do it. So that will give you the situation here, right? So these are the analytical techniques which we use, right? The similarity analysis, predictive modeling, clustering, all these techniques which are using for this data, and the learning data and the learning techniques we can use, right? Deep learning techniques, right? And neural networks for clustering also we can use as a predictive model, and for vague data we use the fuzzy logic, right? So this is how, right? This I will explain in my next uh, lecture. And this is what I was talking about. The healthcare workers must be provided with a graphical user interface, a dashboard type, where the information is conveyed to them. Inferred information is communicated in a graphic form so that they quickly comprehend that and come into action quickly without loss of time. So this is a larger context, right? This is what the we this I will discuss later. This is what I was talking about. Your analytical models which you have built must be periodically refined due to the evolving data, because the data has a value, right? The very recent past data is valuable for analytic purpose. So that we have to refine these models. So you have a feedback mechanism. So this is a continuing process where the data analytic models are refined in view of the new data that is streaming into the databases and used for diagnostic purposes and developing healthcare strategic plans, right? So if I look at the United Nations, World Health Organization has identified, United Nations has identified sustainable development goals. Sustainable we means environment, protect the environment. Our development should not adversely affect the health of the environment, right? We have to protect the health of the environment and develop technologies for good quality of life. So what are the parameters? Poverty, one thing, hunger, food, and the health, education, right? Education will bring awareness in the population about these three basic issues. Gender equality, that is the male-female balance, is very important for a healthy population growth, and clean environment, clean energy, right? All these the 17 parameters have been identified as the development goals for sustainability of the environment and survival of the human species on the surface of the earth, right? And artificial intelligence impacts, out of these 17, right? Seven goals are identified, are impacted by artificial intelligence. So your research in healthcare domain based on artificial intelligence and machine learning is going to impact good health goal, right? And it's going to impact the poverty mitigation measures, nutrition, right, in the form of nutrition, and the good quality education, bring awareness to the population about the need for maintaining the public health, right? And other parameters as usual, right? So the medical domain is duly concerned with these goals, and AI has a big role to play, right? I think with this, I will conclude. I think already I passed 5 minutes past that one.
Yes, sir.
So with this, I will conclude. So the computing paradigms that emerge, that are competent and relevant to this present day analytics, this present context analytics, are the neural network, deep learning networks, fuzzy logic, and what is important is the parallel computing platform should be provided for such a big data analytics, which comes in the form of, you may be familiar with this Hadoop and MapReduce, which will provide a platform and programming environment for such big data analytics in this context, right? And for streaming data in IoT-based applications also pose a challenge. We have got technology and the techniques to handle the big data analytics pertaining to healthcare domain. One of the important aspect of machine learning is the clustering methods. So the very first step of the data analytics is the clustering, because we have got a deluge of data, or ocean of data. So we have to group the data in suitably in the sense of the application we are going to handle, right? What is our decision goal, right? With that in mind, we have to group the data, that we call it as clustering. When you say a group, that is the data objects which are similar type, similar nature, in terms of the characteristics or the information they hold or some other criteria that characterize the similarity, based on which the clustering is done, right? I will start with the talk. Clustering methods we have studied already in machine learning course, right? What we have to discuss in this is the need for new clustering procedures, which are relevant for the challenges posed by the very complex nature of the data we are handling in data analytics exercise. Right? There are various conventional clustering methods, right, which have been very effectively used in the data mining, right? So yeah, I think many of you might have taught the machine learning course also and data mining course also, because machine learning is is a part of data mining, right? So what you must have taught the clustering techniques. K-means clustering is one of the right very popular method of computationally simple, right? And clustering procedure, a very common sense approach, right? We also call it as in a larger sense, we call them as heuristics, right? The heuristic algorithm based on some common sense criteria to group the data into certain groups called as clusters, right? So cluster analysis is very important. It is the first step of knowledge generation. That what data is trying to say is first evidenced in the form of the clusters that are generated from that population of data. And then you do the analysis of these clusters, what each cluster says, and then characterization of that, or subclustering, right? All that you go on doing it in a hierarchical fashion, right? Try to understand, dig more into the greater details of the information content of the data you are analyzing, right? That is the whole exercise here. So clustering is a very important procedure, right, in machine learning, right? And the knowledge that is generated by this clustering procedure is the basis for inferencing through AI techniques. artificial intelligence techniques. So that is the importance, right? And now the cases we have seen in the previous discussion, we have seen the big data context in the healthcare domain and the rich variety of the data, very complex data, and all the 7 characteristics of the big data pertain to medical healthcare data, right? And now, what is the effective way of clustering such data for certain decision making, right? There are various decision making. I told individual patient data, decision making is different, and public health data, the decision making is different. In the case of an individual patient, all his symptoms, all the data that is and monitored data, right, or that is historical data of that patient is also taken into consideration for diagnostic purpose, right? So the complete history of the patient's history in the form of the medical records, right? In all those records which we discussed, he might have preserved it and then produced it in front of the medical expert. So he will understand the history of the patient well with that data. And then he comes out with a diagnosis. That's the decision. And then the strategy for treating the current ailment, right, which the patient is suffering, and what is the course of treatment, and how long, what medicine and how long, and the change of medicine at what point of time. This is called as a strategic planning of the course of treatment of medication of the patient, right? That is at the individual level. Now, we have to, when the large population is at risk, as at health risk, then we have a different, we are working in a different plane, in a big data plane, right? Then we have got a huge amount of data, various form, right? With a big data challenge. Now we have less time, right? We have to act in less time so that the population is not suffering for a long period of time. So this is a challenge, right? That is whatever we don't have the luxury of taking our own time to come out with a suitable solution. After 10 years, if I say for COVID, this is the effective medicine, then in 10 years, people will die, right? I have whatever I have to do, I have to do it in quick time. That is where the analytics becomes very important. Data analytics becomes very important. It saves the time. It reduces the effort, right? When you make use of the computer-based data analytics and then use it for the knowledge generation about the public health or the individual's health, and then use that knowledge for diagnostic purpose and therapeutic purpose. Therapy means course of treatment. For both diagnostic purpose and therapeutic purpose, this analytics is very important, right? And the basis for analytics, from the raw data, we have to discover the knowledge, right? That is that line, from raw data to the knowledge discovery. That is your data mining exercise. That is a path of data mining, right? And we have, from the raw data to the knowledge discovery, we have the clustering method is playing a very important role. Now, we have we have understood, we have fully understood the big data context in the healthcare data. And now the issue is how to gear up or how to scale up these clustering procedure to handle big data context in healthcare data, right? And I will also illustrate how the clustering is effectively used in customer review assessment as a case study, right? And then we can think of the same thing in the medical domain, right? This is something which we have done, and I will present those results also, right? So you are familiar with these clustering methods, which are studied in data mining course or machine learning course, right? Partition-based methods, that is K-means method, and all the variants of K-means belong to this category. K-means is a very simple procedure. You start with that is how many K is how many clusters you are looking into that data, right? So we have that is suppose I'm dealing with a class, right? I'm teaching say the machine learning course or a class of some 60 students, right? Naturally, I'll be looking into the group of students who are who are able to understand the subject very quickly, and some they are not able to understand. Some so, right? They take more understand, but take more time to understand with greater effort. That means you are looking at three categories of students in that class, right? That will help you for your delivery plan in the subsequent course, right? So effectively, to make your lesson plan effective, this information is necessary. What is the portion of the class which is good, and which is a portion of the class which is average, and which is a portion of the class which is below average. We can't say dull, we can't use that word. We can say more dignified word, below average, right? Below average, average, and above average. So if this is, that means your K is 3. So this is intuitive way of trying to understand the data, right? And you feel that I am looking for so many clusters in that data, right? And then you take three data as the seed points, and you assume that they are belonging to three different categories. You are looking for three classes, so you have selected three seed data points as seeds to start the algorithm. Then you take the fourth data point, right? And then you calculate uh, this new fourth data point to which of the three it is nearer or closer with some distance measure or similarity measure, right? To which of the three it is more closer or more similar, right? We require a certain distance measure to measure this similarity, right? And in vector models, because all these, if data are vectors, then you calculate the Euclidean distance. And there are many distance measures, right? Minkowski distance measure or max distance measure. Like there are many distance measures which are available in the literature. Depending upon the type of data and the application you are handling, some measures are suitable, right? And then you group that fourth data point to the one which is closer. That means you have labeled as belonging to that category, one. And the fifth one you take and then determine. And once you add the fourth point to the first category, and then you calculate the centroid of that point, centroid of that cluster, right? The mean of that, right? So every point, every data point in the population, you are going to do that one. So continuously you are trying to measure the distance of the new point with the centroids of the clusters, to whichever closer it is added to that, recompute the centroid of the cluster to which it is added, like that. The centroid of the clusters is continuously updated as and when the new data point is added to a certain cluster. And at the end, you will have the three clusters. This is called as k-means. Means is the centroid. Every time the centroid or the mean of the cluster is calculated, that is why it is called as k-means method, right? So the data set is partitioned into k clusters using this approach, and there are many variants, right? In the literature, you will see, right? These are all partition-based methods. Another one is hierarchical-based method, tree-like structure, right? Suppose if you have, again, same class you take, above average student, again, you can have a subclass there, right? That is very bright, moderately bright, and okay, above average. It is very bright means rank holders, promising students, right? Who can get rank in the university, etc. So that you can give more focus on that student, give him it more literature and help him to solve more number of problems like that. So your plan for that group of students is different because you want your performance of college students at the university level should be good. So naturally you will have such plans depending upon these subclusters, right? So average students, again promising students with little support, they become more bright above average, like that, right? And dull students who can be motivated and become more average, or dull students who are potentially, right, have the potential threat of failing, with proper care, whether we can help them to make pass, right? So your strategic plan differs depending upon these subclusters, clusters within clusters. This we call them as hierarchical clustering. This is top down. You go on devising method or agglomerative method. You start with a group of students, and then new groups are added to these groups, and at the end the whole class, right? So here and here when you divide, I'm only talking about their brilliance in understanding the subject. But a sports teacher or a teacher who is in charge of cultural activities, he will partition the same group of students, clusters them in different way, who are good in music, who are good in drama, who are in sports, right? Who are not good in any of these activities, who are good in drawing, painting, like that, right? So you identify that is your similarity, your criteria for clustering changes, right? That is the skill-based clustering. So now that is how this is another again heuristic approach, right? Where you develop some clusters and then sub-clustering and again sub-clustering in a top-down approach, right? And then divisive approach where bottom approach where you have got some small clusters, and the closer clusters are brought together and make a bigger cluster like that, and finally you reach the root of the tree. So hierarchical structure have a typical tree-like structure, right? And you have got another clustering methods, which are again in the literature density-based. Very popular among them is DB scan, right? Where the density based, that is the that when what we mean by density is how closely the data points are in a cluster. That is more closer, more dense the cluster is, right? So the density is will decide, right, about the clustering procedure, right? So these are some of the standard procedures in the literature, and you have got if you are using Python, if you are using MATLAB, you have got routines to implement all these methods, right? We just have to understand, and we have got Python routines and MATLAB routines to implement all these methods. We don't have to worry about programming. We just have to use this. And grid-based methods, right? Grids, that is a grid-based method, right? And then model-based methods, which is one which is very important for present day context, right? Artificial neural networks, which are of self-organizing type, feature maps, are used for model-based, right, clustering. Neural networks models are very typical model-based approach for clustering. Right, is neural network is trained, right, for different uh, clusters, right, and any new sample is used to categorize. The network will categorize any new input sample to one of those trained clusters, right? One of the clusters with which the neural network has been trained already, right? So this is how you have the classical clustering methods, right, which are used in data mining, right? And for if we have data in a database, okay, we can implement these methods very effectively using Python or MATLAB, right, and do your mining activity, data mining activity. That is data analytics you can do, right? You can build predictive models, right, using machine learning techniques, using regression. You can develop predictive models, right, and make use of them, right, effectively for a single database, right? We have a single model, right, and all the parameters of the model are determined by learning from the data and and using the statistical inference techniques. So all the model parameters are evaluated using the statistical inference techniques and learning from the data, right? And now the present issue is having understood the traditional clustering techniques and the traditional machine learning techniques and AI techniques, which are very well versed in handling single database approach, or a single database application. But now the situation is different. Now we have got right data of very large data and streaming data continuously pouring into the database in databases which is of distributed nature, geographically distributed in various data centers. That means we have cloud-based data, right? How to analyze the data which are there, right? We want to infer the data for a certain application which is largely distributed, right? Large scale distribution and very rapid pouring in of the data, very richly heterogeneous, rich variety, right? And there is a time axis. So you have a data that is time stamped data, right? And data that is poured by the various IoT applications like that. So you have got all the seven characteristics of the big data, right, uh, are there in the medical healthcare domain. In the healthcare domain, all these are very much true, right? So all the seven V's of the big data, how to cope up with all these the seven V's of the big data for clustering for the healthcare data, because health clustering is a first step, right, for knowledge generation, and then deploy machine learning and AI techniques, right? So and that is all analytics we will do after the clustering happens, because I know what to do with the different clusters. I have a different plan for different clusters, different analytics for different clusters. I think in the last slide, where I have in the last discussion, in the last slide, I showed you the intelligent care delivery system. Right? There you have got several analytic procedures for different kinds of data that are segregated, right, by this clustering procedure, right, and all the predictive models that are developed They have to be frequently, every week or every month or once in a year, depending upon what decision you are going to take. These have to be refined depending upon the new data that is pouring into these distributed databases. That is, otherwise, if you still work with the old data, old model, that means the data has lost its value. That is, I'm talking about that last but third one. That is the fifth characteristic of big data, right? The value of the data you are analyzing is very important. If it is very old, that means I am working with an old data model, predictive model for analyzing new data, which is coming with new, that is which is coming out of the new behavior of the data. New, I say data behavior because the system behavior has changed. Environmental system behavior has changed. Right? Your codic, that is COVID virus behavior has changed. Right? Mutation. That is the new strains of the COVID. That is new behavior, mutated variant, COVID variant. That itself pose will change. So the new health data will reflect the effects of the mutated strain affecting the public health. So how do you capture this? Right? That is where this aspect of value, data value becomes very important. I have to continuously capture the recent data and update my predictive models, which are built using machine learning techniques, revise them, refine them, and again put it to use for the analytics of the recent data that is captured. So it is a continuous, ongoing process, right? Otherwise, the value property of the big data will be lost, right? And variability, that is the same thing doesn't hold. What is true in England doesn't hold good for India. What is good for India doesn't hold good for African continent. What is good for this doesn't hold good for Europe, doesn't hold good for the Asian continent, like that. So these variabilities, how do you capture? That means all these models which are trained and and all the countries agree to share this information. Sharing the data means sharing the knowledge also. But these models have to be refined, retrained with the data that is pertinent to that location, right? So whatever scientists, whatever data models, predictive models the Indians have built, Indian scientists have built, I can share with the Russians, I can share with the English, I can share with the Japanese, I can share with the African scientists. But they cannot use those predictive models as it is. They have to retrain or refine that model with the data local to them. With the local data they have captured, they have to retrain, refine. That means upgrade that model and then analyze that data, right? Analyze their data. Then only they will get good inference. Otherwise, it will be useless. So all these value and variability become very important aspects, right? They are very important not only for precision in decision making, but also the cost involved in this exercise. I've told you, right? Millions of dollars are invested in this exercise. So we should be more precise in arriving at the decision, right? Good quality decision depends upon good quality data used for good quality models, right? Predictive models. So your decision making will be more precise. And your resources which are consumed by the strategic plan based on these good quality decisions will be saved. You are saving in time and you are saving your resources. You are, the vaccines which are developed, they are very costly resources. I cannot waste, right? I should identify the target population that should be first prioritized and vaccinated. So you have to target, you have to determine the target and prioritize the target population and subject them to vaccination exercise in a big way. Then only your resources are consumed appropriately. So all this, how do you plan? Based on the analytics of this data, right? The data scientist who has the responsibility of analyzing this kind of data, right, at such a large scale and in such a quick time, he should come out with the plan for with the recommendation for the strategists to come out with strategic plans. So that recommendation or the final decision making, all what we are discussing is for that purpose. Right? So all world over, scientists are already engaged in this. We are discussing now, but already the governments have employed or asked the data scientists, right, to work in collaboration with the strategic planners, healthcare planners, to recommend them suitably by making use of the current data that are captured online. So they have a time series data that is monitoring this the pandemic, right? So that data is used. But as a computer scientist, we have to see what is the research in it, right? The research in it is enormous. Research opportunities are enormous, right? And one of the opportunities is how you can improve or scale up the clustering technique for this big data context, right? What are the techniques that are required? What are the technologies that need to be developed, which will address all these properties of this big data in medical domain, right? That is what we are discussing here. This is what I just said. Data is richly heterogeneous in nature and resides in distributed databases or cloud environments. So that is your research, right? So what is the technology that you need for your research, right? When you have a distributed database and your data files are very effectively, right, handled by the Hadoop framework for access to distributed file system. So you can use Hadoop technology as a framework for access to the distributed file system. And then you require a programming environment, right, based on parallel computing. And MapReduce is the technology, right, uh, which is accompanying the Hadoop, right? Right. So the Hadoop is combined with MapReduce. So it produces, right, this Hadoop framework with map producing computing environment, right? You have you have the relevant technology to handle this distributed database, right? And then do analytics on that, right? So this is that means if you want to do research, right, in for addressing such issues, right, uh, big data issues in medical healthcare data analytics, then you have to familiarize yourself with the Hadoop technology and the implementation of the MapReduce for parallel computing, right? So this is what you will use for the data analytics programs implemented using MapReduce. And the access to the data is through the Hadoop file system, HDFS, right? And now if you are working with the cloud-based data environment the database technology for such a distributed environment, the latest one is the blockchain technology, right? So you have got the all the database issues are taken care in the distributed environment in blockchain, the updating the data, integrity of the data, right? And all those things, database, data integrity, data security, and data updation, that is, then only it is all these 7 V's are taken care in this blockchain technology. Then how do you do analytics on such platforms? So this is the research area, right? So you don't have to do all this because each one is a research topic by itself. You fix one of the research issues and start working on that, right? In my narrative, I have exposed all the opportunities where you can, what you are good at, there you pick up a research issue and then define your problem, research problem, and then come out with the objectives of the research, right? And then you develop methodologies, right? Or techniques or algorithms with the healthcare domain or medical diagnostic domain, right? All these are or do data, research in database itself, because the medical database, right, at the hospital at a lower scale, or at a particular clinic at a lower scale, at a medium scale in a certain hospital, at a big scale, very big scale in corporate hospitals, or if you are dealing with public health data. So you have got data that is originating in public health centers or Department of Health and Family Planning. They have public health data, right? And they and the NIC, right? That is National Informatics Center. NIC is supporting this data gathering and storing activities. So all the district, every district has NIC center, right? There we have public health data, right? Distributed spatially. I was referring to geospatial temporal data. This data is available in the NIC databases. So if you, yeah, that is NIC, that office, NIC center in the office of the district magistrate, right? District collector, or what we say, deputy commissioner's office. If you go there, they will tell one information officer, that is NIC officer will be there, right? And they have a computer center where all these agencies, all these public related data, and in particular for our context, health data captured through the government departments is stored in the form of databases, right? If you go to APMC, there also you have got computerization, computer databases where you have got data related to agriculture sector. That data again, spatially distributed, temporal in nature, is captured, stored in those databases. So if you have fixed your research problem in a particular domain with a particular research issue, and then objectivized your issues, and then you have to look for the relevant data where it is available. The repositories of such data relevant for your research only must be accessed. Otherwise, it is a washing. It is a big washing, right? So this is how the preparation of the data, right? Data preparation for your research is also a research activity. It's the first step of research, right? You cannot start data preparation unless you identify your problem statement and the objective set. Only after that, right, the step of data preparation for your research starts. And the repositories of these data are in public databases, right? Some which are recommended for research, because all researchers make use of the same databases for the research, and you will be able to compare your algorithm results with those authors who have used the same databases for their research. right? It will provide these the public data provide a common platform for researchers to compare their results with their peers' results. Right? That is how we go about so far as the data sets are concerned, right? But if you are working in big data analytics in the healthcare domain, the challenges are, right? So you have to identify the relevant technology, the computing, the database technology, and the computing environment, that is parallel programming. So that comes, that is in the form of Hadoop and MapReduce. And the present day researchers are making use of these two. And the latest database technology, that the blockchain, is throwing up a new challenge for data scientists because they have to now uh, uh, scale up or upgrade their data analytic techniques for data residing in blockchains. That is the research area, right? This is I'm just trying to concentrate on and what algorithm, and some people are working only on some people are some people are working only on clustering, right? Because clustering is a very important algorithm. So clustering procedure is a research area. Why it is a research area? Because on what data and on what site the data sites, the nature of the data and the nature of the data sites, right? That will limit your data access, right? How do you access the data, right? For this kind of data which is residing in such data sites, data centers, right? So that itself throws up a challenge for research in clustering, right? So some researchers are focusing only on coming out hybrid clustering algorithms which are competent to for this kind of database and data environment and computing environment. And the latest challenge that is thrown up at the data scientist is the blockchain, right? You catch the one of these threads of research and then come out with your own contribution in this area, right? And another domain where people are concentrated, that is the geospatial temporal nature of the data. That arises because of the IoT intervention in medical domain. You see the patients which are right monitored by so many biomedical equipments, electronic gadgets on a continuous basis. So you have a streaming data by various sensors telling about the current, that is the instant health of the data of data of the patient, and GPS data, that geographically distributed data. You have got GPS data also, right? So if you have got applications making use of the data streaming by the IoT and GPS applications, right? The Arigya Setu app is a typical example. Arigya Setu app, the government of India has come out, and millions of people are making use of that Arigya Setu app, and all that data is helping the government agencies to come out with a strategic plan. And based on that plan, as a sample data, they are going to come out with a strategy for vaccinating the Indian population, right? So this is the largest scenario, very big picture I'm talking about. But lot of research effort goes into this, and the fruit of this must come out in quick time. Otherwise, the population will suffer this pandemic, right? So if you want to mitigate the human suffering due to the current pandemic, then lot of research effort goes into such applications, right? And information retrieval, web-based information retrieval. I'm talking about this in a very quick time, right? I'm going to spend some time on, and I'll tell you information retrieval procedure, and we can implement the same procedure for healthcare data also, right? And for clustering, right? The present this one is the neural networks, right? Because of the enormity of the data and the enormous number of clusters that need to be generated as a knowledge, right, basis for the AI applications, right, to draw inferences, right? So we have this is again a research, right? What I'm pointing out is employing deep neural network for clustering, right? Such rich, heterogeneously rich data, right, for information retrieval, right? So this is a research area where you can not one thesis, you can have right a dozen theses coming out in this direction, right? We have a lot of research effort is required to work on this. And now having done this, how do you evaluate the clustering algorithm? Whether it's good or bad, or whether it's a good clustering or a bad clustering, how to know, right? So we need criteria for evaluating the clustering procedure that you have come out to handle big data in this domain, right? So we have to think of criteria in terms of the data type, right? In terms of the volume, in terms of the velocity which the data is originating, and in terms of this velocity aspect is very important because these any clustering model you develop have to be refined, revised very frequently depending upon the velocity feature of the big data and the constraints arise due to the streaming data and the real-time actions are required, right? The real-time actions required, right? They are decided based on the streaming data. They are the constraints, right? So we have to do the clustering subject to these constraints. I cannot take my own sweet time to cluster and come out and prepare for addition. And we take addition and already the time of action has been lost. That means this is a waste, right? So you have got a constrained clustering, right? This is a research area. What I am talking about, this is a research area that is constrained clustering is a research topic, right? And there are outliers or noisy data. How do you handle it in a big data context of health domain, right? Our clustering should deal with these outliers and noise very effectively, right? That means the precision of clustering should not be lost due to the presence of these outliers, right? So we must be able to identify them and throw them out, right? Stability of the algorithm, that is very important issue. That is every time I run the algorithm on the data, I must get the same good quality result. The precision of the result should not change when I keep on applying my algorithm to the data on a continuous basis. And this is directly pertinent to, right? This stability is affected directly by the temporal nature of the data, right? So that is why the need for refining the data models which are built, they need to be refined on a continuous basis so that the algorithms work effectively with the same efficiency, right? This is again a research area. And high dimensionality of the data, right? High dimensionality means a large number of features, right? It is a vector representation because you are doing cluster in a vector space model because all your data record is as a vector. So it is a data point, it's a vector in a vector space. and high dimensionality of the data, because you want to encompass all the features that are relevant to speak about the public health or about the patient's health. Then the dimensionality increases, right? Then you have got you have to use dimensionality reduction techniques and come out with efficient algorithms, right? And cluster shapes for visualization purpose. You require a dashboard to convince the strategic planners or decision makers how the clustering of the is done. For example, geospatial clustering of the data, for which portion of the population, which area is largely affected. That is a large number of incidences of COVID just distributed. If you give a graphic display of that distribution, see the Maharashtra, Karnataka, Tamil Nadu, and they were the early states which were large incidences were there. In other states, less incidence was reported. So this gives graphic description or display of these incidences will help. That means require, that is, clustering results are displayed in a graphic form, right? That visualization is again a research area I've told you already, right? That will help the planners comprehend the situation and come out with strategic plan in quick time, right? That is the importance of this research. And what is the similarity you measure in clustering? I told about k-means clustering, where distance between two data points or distance between two vectors, we have to calculate. That distance measure is the similarity measure, how closely it is, right? And in the literature, there are many, right? Distance, that is, as a similarity measure, smaller the distance, closer they are, more similar they are, right? That is the meaning. And you have got cosine similarity, that is two vectors uh, which make an angle, right? That is dot product of two vectors will give you a cosine measure of similarity, right? If the angle is zero or almost zero, that means collinear. That means they are of the same type. So the cosine of the angle between two, which we compute using dot product of two vectors, is a cosine similarity measure of measure whether two data vectors are close or not, right? So this is how similarity measures. There are many in the literature. Dozens of similarity measures have been defined by the researchers. That is, you can also propose your own novel similarity measure, which will give a very effective clustering of the data, right? That's how the research proceeds in proposing new similarity measures and new right, and meeting all the characteristics of the big data. That is our research, right, in this direction. And I will give you one simple example, right? Very quickly, I'll give you one application of clustering which we have done in a customer review assessment. Right? That is in a web that is in e-commerce, web-based, right? In websites, there is a provision for customers to post their reviews on a certain product, and these products is on a continuous basis since it's a web-based application. Right? In the website, customers see the product, buy the product, put their experience in the form of a review, either their own experience or their friends' experience, right? All like that. Somehow the reviews are posted, right? And they are highly unstructured, ungrammatical, right? Some words, right? Some reviews are posted. This is a feedback from the market environment. It is very important for the product manufacturers and the marketing people, right? So they can strategize the marketing strategy. They can come out and bring out the new product features in their product to capture the new share of the market, right? To address or to appeal to the new population, market, customers. So this is the strategic plan. It depends largely upon how do you cluster this customer review assessment. That was uh, so we have made use of one quartile measure, and we have done another approach, feature clustering. Feature clustering means the product features of the product, right? They are clustered using statistical technique, and then review clusters, right? The cluster is a vector, right? That is each product is as a vector. Each review that is posted is viewed as a cluster in the vector space model, and the clustering is done. And the dimensionality reduction is also has tried to for using principal component analysis, right? This is a typical line of research that one does, right? Very quickly, I will give you how the customer review. I think you are able to see this one, right? Customer reviews and ratings on products, top rated products, right? Customer supplied photos of the product. All these are the reviews which are very which these reviews are very important in provide product ratings, right? And once you this then the prospective buyers, right? This product reviews and ratings will help the prospective buyers to arrive at their purchase decision, right? That is why a lot of effort is spent on for this purpose, right? So the one is important is how what is the quality of the analysis. This is again a data analytics exercise, and here the data is the customer reviews that are posted in the website and stored in the database, right? So we are handling a single database where all these reviews are posted, right? And we have that I am not explain how these reviews, right? We have got NLP approach because these are English. We have taken English as the language for our customer review, and then the opinion of the customers on the various product features, right? Good, bad, right? High, high, precise, good color, pleasant color, right? On the color and all those things. What are the product? What are the features of product on which the customers have commented upon, right? They are the product features, right? And different people have give importance for different product features. So you have a host of customers who have posted 1,000, 10,000 reviews. So what are the product features upon which the comments have been given? We have to gather that one. That is the job of that is the task of NLP. So using NLP technique, these reviews have been analyzed, and all the product features upon which the comments have been given have been gathered, right? From thereafter, the present analytics starts. Having given that, right? Having given that, right? Each customer review has been subjected to NLP procedure, and all the product features have been identified and stored in the database as a vector, right? Review one, right? On which feature this review comments upon. If it comments upon a particular feature, the entry is 1. No comment done, the entry is 0. So I will prepare a vector. If there are some 100 product features upon which comments have been made by this population of customers, right? So I'll say 10,000 is the population of reviews, right? So I have got 10,000 vectors, and each vector is of 100 long, 100 component long, because some have commented on some features, some have not commented on some features. If they comment upon good or bad, that we'll see later, right? If it is good or bad, if you're, then you are talking about the polarity of the review. I'm not bothered at that stage. And now I am only important on which product features have become important for evaluation by the customer. That I want to know. So polarity I am not considered, right? So now, if on a particular feature, on a color, or if it is a camera, you talk about the resolution, right? The pixels, how many pixels are you, what is the color, right? And etc. So many features you can talk about, right? So if a review comments on a particular feature, then the entry, the component is one. That if the no comment is on particular feature, that component is zero. That means you have a vector 100 component long, and the entries are either one or zero, right? So 1,000 such vectors. Right? So my NLP procedure has generated this vector space model of 10,000 reviews, 10,000 vectors. That is my data. Now I am working in the vector space, and all my reviews are as vector points, as data points are vector points in this space. 10,000 points are there. Now my research issue is how to cluster these 10,000 points, right? So that I can come out with a decision for my marketing purpose or product improvisation purpose. So I intuitively I identify most significant review, that is the features which are very frequently commented upon, that is high frequency, high rank components, that is high frequency components, and then more significant, that is lesser than this, and still lesser commented upon is the significant review. And insignificant review means those features on which many people have not commented upon. That means those features are not so much relevant so far as the marketing purpose is concerned, right? And some features are very important for the product to impress upon the customer. This is my research objective. So if this is my research objective, this is my intuitive uh, groups I have identified, then I am looking for four groups, like four clusters. Now the issue is how I should cluster this. Right? So how I this I this one this system flow will just tell from the web page where you capture the view, store it in database, and then identify the features and generate a feature vector space, right? And from there we start right from the feature we start the clustering, right? That's all. So now this is what I would tell. This is we call it the review matrix, right? And here I am talking about a camera as a product, right? So camera as a product, and so many m number of reviews have been posted on that particular product. People have commented on the price. It's a high price, unreasonably high. It's okay, moderate price, right? Right, like that. And picture quality, and the zoom in, zoom out, the speed, the time, and the battery life is also important feature for the camera, digital camera, and the memory card and the warranty. So like that, on various aspects of that product camera, people have commented upon. You have to list that one. You can't ask the customer, you comment only on this particular aspect. Customer is free to give his comment on the product as a whole. On different aspects, different customers give the comment. You have to capture all those aspects or the features of the product on which people have given the review comments. This is the NLP. The NLP will give this list, right? Or the dictionary of words based on which comments have been given. And this one means the review has commented upon the price, and there this review comments upon the battery life, like that. And now I have one such 100, that is 10,000 rows for 10,000 comments. So each one is a vector in the vector space model. Now, if you add the column wise, you will get the frequency of the reviews, right, which comment on price. The second column sum will give you the frequency of the reviews commenting on picture quality, like that. Each column sum will give you the frequency, right, distribution among the various features of the product. And now you arrange them, arrange these features. Now arrange these features depending upon the highest frequency and then in the descending order, right? So you can give rank for the feature depending upon the order in which they have been arranged in terms of their frequency. So the highest rank for this feature, second rank for this feature. So you have the ranking of the features of the product, right, based on this information, right? This is a very simple statistical exercise. You just have to do the column sum in this table, right? So our database has this table of information, and then statistical analysis will give you the frequency distribution among the various features. And now I will rank them, right? Ranking the various features of the product according to the importance of the feature people have commented upon, right? So this is the frequency, this is rank-based frequency distribution chart. And now what we will do, having done that, right? Having done this ranking, what we will do, the quartile measures, that is, I will identify that frequency value where 25% of the data lies in the first quartile and 25% of the data lies in the next quartile, right? And 25% of the data lies in the next quartile, like that. So identify maybe the first two features here are responsible for 25% of the data. That means these two features are responsible for the most significant reviews given by the on the product, right? So 25% of the people have commented upon these two features. That means these two features are very important so far as the marketing is concerned. And the next 25% maybe these some 3 or 4 features may be required for the next 25%, because you see the frequency is reducing, that the population of the data is reducing for each feature. So some next some 4 5 for average, and the last few features that is least significant reviews 25%. So this is a heuristic that has been developed for clustering based on the quartile measure distribution of the frequency, right? That will give us the data, the results we have given for 4 products. For digital camera, we have done this, right? Out of these total camera reviews, we have out of the column sum will give you the total reviews. Out of that, 244 are identified as significant, 128 significant, 77 significant, insignificant. And the whole exercise is repeated for different products. For car as a product and its features, mobile and its features, and then MP3 player as a device. So from the publicly available the review databases, we have picked up and done and implemented this heuristic algorithm based on a very simple statistical procedure, and we are able to come out with results, cluster them, right, accordingly, right, based on the quartile measure. That is what I was talking about you. You come out with your own similarity measure to do the clustering, right? And you see how effective it is in for decision making. And this is the knowledge generation, right? From the raw data, I have generated the knowledge. What is the proportion of reviews which are more significant? What is the proportion less significant, etc. Right? And what are the features, right, addressed or commented upon? Product features commented upon. In these more significant features is the important knowledge generated for the decision maker. Same thing for any activity. And this again, we can as well adapt it to healthcare data, for agricultural data, because it's not specific. Once we transform our data record to a vector space model, and in the vector space model, in the data record is a vector representation, and we have a vector space model for the whole data records, data set. And in that data vector space, we do the clustering, right? Only thing intuitively I have to identify what are the clusters for that application. So this is how very effectively that has been done. Then this I will skip. How does it compare with our k-means or fuzzy C means? These are also standard, right, textbook algorithms. We have compared this quartile measure. We see that these are more complex, algorithmically more demanding, computation intensive compared to the quartile measure which I have proposed. The effectiveness of this clustering is same as the k-means and fuzzy C means, but at lesser computational cost. That is very important, because when you move to big data context, the time complexity becomes very important. If this simple quartile measure will help me to do the clustering in less time, then I can adapt it to for big data context. And this is a point of research. Anyone can pick up this and do this one, right? And clustering approach, here again, instead of uh, uh, instead of instead of clustering the features of the product, when you have the vectors, that is, each review has a vector representation in a vector space, why not cluster those vector points itself, right? That is a review clustering, right? So you have got the data, right, accordingly. And maybe I think we have used the Euclidean, I think maybe we have done Euclidean distance, right? Once you have that, the dimensionality reduction, right? That is PCA, principal component analysis, right, on these clusters, right? That will give us the reduced number of features, right, on which I can focus upon. So the marketing manager, right, now he is more precise, right, about the which reviews he must look into, he must read and take it seriously. So out of thousand, right, hundreds of reviews, so he is able to pinpoint those reviews which are significant enough for his decision making, right? That is the utility of this these research results, right? We have identified, and this is all published work, right? And if you have got span, this I won't give to. We have worked on this one also. We have developed measures. I think this is time now. I will conclude. I think it is time now. I will conclude this. So the whole focus of the discussion here is how to adapt the clustering methods, which are the first step of any machine learning task, right? And then adapt it to the big data context uh, in various sectors, especially in medical domain. Agriculture, healthcare domain is one big thing. Agriculture domain is another big domain where these technologies make a great impact affecting the human life. Right? I think with this I'll stop. If there are any questions, these
Yes, sir.
are some of the references,
Yes, sir. Few
and
questions are there.
these are our own research is there, right? right? Okay.
Yes. Sir, a few questions are there.
Right. Okay.
Can you please share some resources to study machine learning application in
Right.
healthcare industry?
As of now, I think some books also have come out, right? I think we can Google it. Many books have come out on healthcare data analytics, right? That is not a problem, and research papers are also there, right? Because it is a research area, I think I focused on the adapting, right, uh, machine learning and AI for big data context. There we have to rely on research papers only because it is still a focus of research activity. We will not get it in books. Books are there, no problem, right? We can
Sir,
find.
one more
Okay.
question.
I here have, I think in reference I've given one example I will give. In 2014 itself, this paper has come, clustering in extreme learning machine feature space and such survey of clustering, right? And these are some of the right papers, right, where you can see the focus. But the point I discussed is the that is adapting machine learning techniques for the big data context evolving in healthcare domain, right? That is a research area. We have to look for papers, right?
Okay, sir. Sir, one more question. What are
And
the
I think I also made a mention that is these researchers have made use of the Hadoop platform for data access, and they have used MapReduce as a computing environment for parallelizing the computation required for data analytics. I think I have answered the question.
yes, sir. Okay, so one more question, sir. What are the prerequisites required to do research in medical and healthcare unit using machine learning?
I think I mentioned that already. If I want to do research in this domain, machine learning used for health data analytics, I have to start with right single database, that is conventional machine learning techniques. All our undergrad courses also do that one. Is good enough for a project. But if I want to do research, I have to scale up to big data, right? And the data is available. Healthcare data is available. I mentioned in NIC databases in public domain. If you approach NIC, they will be able to share the data, which is of geospatial temporal data is available for research, and that is no issue, right? Only thing I have to learn the Hadoop technology and then MapReduce technology so that I can implement my algorithm. So that is the first thing. I have to learn those things. The technology I have to learn so that I can implement my algorithm with those technologies. Data is available in the government sources. That is about healthcare. But the problem is with the hospitals. Since it is patient data, a lot of legal issues, ethical issues are there. As an institution, you have to enter into an MOU with those hospitals. Then only they can share the patient data for the researcher because both institutions are responsible for the Privacy Act. If any legal issue arises, then the institutions will be responsible because they are the custodians of that patient data, right? So there are legal ethical issues are involved, and ethical committee has to be formed both at your institution and at the hospitals who share the data. They have to sign the document. It usually says I will use the data only for research purpose. I will not give it to any other person. If it is, then the legal issues, legal cases will be attracted, right? So a lot of that is why it's very difficult. So if anybody who wants to do research, we have to rely on publicly available databases, right? because they are specially published databases for the purpose of research, right? I think I have answered that question.
Sir, next question. Which clustering method is good for image data?
Uh, Clustering all there are not one, right? Which clustering depends upon the clustering procedure and which similarity measure is used. In the literature, we see different methods, right? Making use of different similarity measures, right? For different problem, different clustering techniques and measures. We can't say this particular procedure and this particular similarity measure is a Ramabana for everything. We cannot say that one, right? That is why it becomes a problem or application dependent. I thank all the participants for the patient hearing during both the sessions. And I also thank the organizers, especially Professor Sharmila Kumari, for inviting me and giving an opportunity to interact with the participants. And also Professor Saifuddin for hosting the two sessions. Thank
Thank
you.
you, sir. Thank you, sir. Yes. Now we have come to the vote of thanks. I, on behalf of Department of CSC, PA College of Engineering, feel privileged to wholeheartedly extend my gratitude of having Dr. Prakash S. Hiremath, sir, Professor, Department of Computer Science, MCA, KLE, College of Engineering, BVB CET Campus, Hubli, as the speaker of today's session. I am sure the fine grained theory concept would have given all the participants a complete exposure in materializing and understanding even the highly complicated topics in the simplest way. I affirm that the participants will have a lot of takeaway from this highly knowledgeable session and have an exponential leap in their research progress. Thank you for such a wonderful and highly informative session. Thank you, sir.
Okay, thank you very much.